Okay, good morning, afternoon, or evening, everybody. Welcome to the Sentinel-1 Data Access with NASA ASF DAAC's Vertex tool, Earthdata webinar. This is your host, Jennifer Brennan. For most of you, you've already noticed this, but while you're logging in, we do have two optional polls at the bottom left and middle portion of your page, and we appreciate your feedback on these polls. I do have 3 p.m. Eastern Time, so we are going to go ahead and get started. What I'd like to do first is review a few logistics related to this webinar. To ensure the best audio experience, the conference has been placed in silent mode. But if you have any questions or if you have any issues, what I'd like for you to do is enter those into the Q&A pod, and you'll see that located on the lower right-hand corner of your screen, and this works like a chat. Excuse me. This webinar is being recorded, and we will have it posted both to our online Adobe Connect webinar catalog as well as to our NASA Earthdata YouTube channel within a few days of completion. And I do plan to provide both the URLs to the channel and the catalog as well as the presentation files being available for your download at the end of the webinar. As far as timing is concerned, this webinar is 1 hour long. We've allocated 45 minutes to the presentation and live demonstration with an additional 15 minutes for the question and answer period. After our speaker has finished his presentation, what we'll do then is we'll move to a final set of polling questions. And then from there, we will transition directly to the Q&A period. You will have an opportunity to ask your questions throughout all portions of the webinar with the exception of the live demonstration by using the Q&A pod. Again, this does work like a chat. Due to the large number of participants during today's webinar, questions will not be answered using the raising hand function. It has been disabled. And then just one final note, depending upon the volume of questions that we receive today, we will extend the Q&A period an additional 15 minutes to 4:15 p.m. Eastern Time for those of you who may wish to stay on the line. During today's Q&A session, we will have 2 additional panelists available to answer questions. Those individuals are Vicki Wolf, who is the Sentinel-1 product owner at NASA ASF DAAC, as well as Jean Laurencel, who is the Vertex product owner. Let's move next to the agenda. I'm going to pull that up for all of you here. Excuse me. Okay, during the first few minutes of today's webinar, our speaker will provide an introduction to the NASA ASF DAAC and also to synthetic aperture radar data. From there, we will spend about half of the webinar going over key features and functionality of the NASA ASF DAAC Vertex tool. Finally, our speaker will take all of you through a live demonstration of how to use Vertex to discover and access Sentinel-1 data. Finally, we will wrap up today's session with a summary. And with that, it is my pleasure to introduce today's speaker, Bill Hauer, who is a science consultant and also a member of the NASA ASF DAAC user support team at ASF DAAC. Bill?
Welcome, everyone. The ASF Distributed Active Archive Center is one of 12 DAACs across the U.S. that are funded by NASA with specific responsibilities for the production, archiving, and distribution of Earth science data products. The ASF DAAC was created in 1994 through an agreement between NASA and the University of Alaska Fairbanks. It was charged with the responsibility to process, archive, and distribute synthetic aperture radar data, or SAR, to a large and diverse user community. The ASF DAAC archive contains radar data and derived products since 1978, when the first satellite-borne SAR sensor began Earth observations. Briefly, SAR is a high-resolution radar on board a satellite or aircraft that generates a series of electromagnetic pulses directed at the Earth's surface. When a pulse encounters the surface, it scatters, and some of the energy is reflected back at the antenna. The type of scattering and the amount of energy returned depends on the surface characteristics. This returned energy can then be processed into an image. Synthetic aperture radar is an active sensor, meaning that it generates its own illumination of the Earth's surface and therefore is able to image at night. The wavelength of the microwave energy is sufficient to penetrate most cloud and smoke cover. These characteristics and others give SAR imaging some distinct advantages when used for Earth observation. The most recent additions to the ASF SAR DAAC archive are data from the Sentinel-1A and Sentinel-1B satellites. These are part of a family of Sentinel satellites being developed in support of the European Commission Copernicus Earth Observation Program in partnership with the European Space Agency. Sentinel-1A was launched in April 2014. Operational data from this satellite were made available for distribution on October 3rd. Sentinel-1B was launched on April 2016, and data were made available on September 15th. Each satellite has an onboard C-band SAR sensor, and each has a 12-day revisit time, which translates to a 6-day repeat period since the satellites work in tandem. The ASF DAAC was selected by NASA to become an archive containing the complete Sentinel-1 historical missions data and to be a U.S.-based distribution center. A major ongoing effort at ASF is to provide users with the fastest and most reliable downloads possible of Sentinel-1 data products. Today we're going to explore one way of accessing the ASF DAAC data archive using ASF's powerful search and download tool, Vertex. Vertex uses a browser interface, so it's familiar for users of Windows and Mac OS X operating systems. It lets users create custom searches. Search results can be sorted and filtered. Search results can be visualized on a world map or through thumbnail and browse images. And data files can be downloaded one at a time or in bulk. You can navigate directly to Vertex by using the URL or start from the ASF website landing page and use the 3 locations that provide links to Vertex. When you open Vertex, a pop-up window appears that gives you the chance to use interactive demonstrations to learn about the 3 different search types. This window will appear each time Vertex opens, unless you click the Do Not Show Again box. Note that these same interactive tours are easily accessed at any time during your Vertex session. Close the window to begin. We're hoping that many of you today are new to Vertex and unfamiliar with its use. For those of you who are more experienced users, features have been added or improved on recently that you might not be familiar with. So let's explore Vertex. When we're finished, we'll see how these features are used in a live search and download demonstration. Let's start first with the top menu bar. The Interactive Tours link gives you the opportunity anytime to learn how to set up a search using the 3 search types available in Vertex. The Help link provides how-to videos and step-by-step instructions for searching and downloading SAR data. The ASF Home link opens the ASF website in a new window so the current Vertex session isn't interrupted. This might be helpful if, for example, you want to find out more detailed information on the data sets available to use in your search. Earthdata Login is used to log into Vertex with your Earthdata username and password. Logging in is required to download data, but isn't required for you to search or to download metadata from a search. If you don't have an Earthdata user account yet, click on the Earthdata Login link, then click on the Register button and follow the instructions. The download queue is where data are placed to download, and we'll talk about this process in more detail later on. The Contact link provides a way to contact ASF user support with any issues, problems, or questions you have, or to offer any suggestions you might have for making Vertex better. The world map is used for defining a search area and is where the spatial coverage of your search results is displayed. The map can be displayed as a satellite image, which is the default, or as a map showing borders, towns, roads, etc. Navigate around the map by holding down the left mouse button and dragging. Use the plus and minus buttons in the upper left to zoom in and out on the map, or use your mouse wheel. A South Polar View option is available for searching for data over Antarctica. The mosaic of Antarctica used in the South Polar View was created from RadarSat-1 SAR images acquired during the 1997 Antarctic mapping mission, in which ASF was a key player. It provided the first complete cloud-free view of the continent. The tabs and menus to the left of the map are used to select the type of search to be performed and to set the parameters necessary for each type of search. 3 types of searches are offered: by date and geographic area, by granule name, or by UAV SAR or Air SAR mission name. The most commonly used search is the Geospatial Search, which requires 3 parameters: a search area defined by geographic coordinates, a range of dates over which the data were collected, and an appropriate SAR sensor. There are 3 menus in the Geospatial tab that allow you to set these search parameters. The Geospatial Region menu, which is open by default when Vertex starts, has 2 options for setting a search area. The first is to draw a bounding box on the map. Place the mouse cursor over one corner of the search area and click the left button once. Move the mouse until the search area is covered and click the left button again to complete the bounding box. If you click inside the bounding box, grab points appear that let you create a polygon that more closely fits the shape of the desired search area. The second option for defining a search area is to use geographic coordinates entered in the coordinates box under option 2. Enter the coordinates in decimal degrees and in a counterclockwise order. After entering the coordinates, click anywhere outside the box to finish. The Date menu allows you to define a discrete period of time for a search by using start and end dates. Make sure the dates you use are appropriate for the data set you're using. For example, a search for PALSAR data in 2012 won't return any results because the ALOS satellite mission ended in 2011. The default start and end dates encompass the oldest to the newest data sets available from ASF. The seasonal search option allows you to restrict a search to only certain months in a year, and this can extend over multiple years. The Dataset menu shows the platforms used to collect the SAR data available from the ASF DAAC and lists them from most recent to oldest. This menu lets you select one or multiple data sets to use in your search. By default, the Sentinel-1A and 1B datasets are selected when Vertex starts. Select or deselect datasets using the checkboxes or use the Select All or None switch in the upper left. The years for which data are available for each platform are shown to the right of the platform name. Clicking on the date range for a data set or on the information icon to the right provides information for that data set, including the precise dates for which data are available. This is useful for making sure that the date range you set for your search corresponds to actual data availability. Click the Reset button to return to the default Vertex settings and the original map view. The second type of search available in Vertex is a Granule Search. This lets you search using a granule name or list of granule names entered into the granule list box. Because the granule naming convention is unique to each data set, no other information is needed for this search. Click Reset to clear the box. The Missions Search option is specific to the UAV SAR and Air SAR data sets. These data sets are from airborne SAR platforms, and the data are grouped by flight lines or missions. You can use a geospatial search for these data, but they're also searchable by mission name. Typing in the Search Missions List box will offer suggestions for existing missions based on what is being typed. And here's a hint. Most mission names include the geographic area they cover. Once a mission has been identified, click the Search Mission button to display the data. The Dataset Missions list displays a list of the names of existing UAV SAR or Air SAR missions. Click on a mission name in the list to display its data. Selecting a mission using either of these methods will offer you the same download options that Geospatial and Granule searches do. So now let's create a search so we can talk about sorting and downloading the results. In the following example, we're going to create a geospatial search. We'll search for Sentinel-1 data acquired over central Italy for a period just preceding to just after the earthquake that occurred there last August. This example will also provide a review of some of the features in Vertex we've discussed that are used to set search parameters. First, I'll log into Vertex with my Earthdata username and password. I can tell that I'm successfully logged in because a message appears in the top menu bar that says Log Out Bill. We use the map navigation and zoom features to move to our area of interest over central Italy. In this case, we'll choose the World Map View option that displays cities and towns. This will help us locate our bounding box extents. As you zoom in on the map, more details will be displayed. To draw the bounding box, click once on one corner of our area of interest, move the cursor to the opposite corner, and click again. To fit the search area a little more precisely, click inside the bounding box and use the grab points to shape the search area. Note that after the polygon has been drawn, the coordinates are displayed in the coordinates field to the left of the map. These can be copied and used to duplicate the search area in later searches. Since the earthquake occurred on August 24, 2016, we'll set the date range to search for data acquired from near the beginning to the end of August. In the next step, we'll select the dataset or datasets to use. Looking at the datasets list, Sentinel-1A and 1B data should be available for the date range we've selected. But opening the dataset information modal for the Sentinel-1B satellite shows us that data were not available yet when the earthquake occurred in August. So we can keep the Sentinel-1A dataset selected and deselect Sentinel-1B. All the necessary search parameters have been set, so we click the search button to begin our search. During a search, results appear in a scrollable window to the right of the map, and search progress is displayed at the top of the window. You can stop a search at any time by using the stop button. Be aware that for large searches, the results will often be truncated to keep the search from taking too long and possibly failing. When this happens, a message will be displayed at the top of the results window during the search. Then, when the search is complete, a window will show how many of possible results were truncated and will suggest ways for avoiding this, such as using a smaller search area, limiting the date range, or selecting fewer data sets. When the search is finished, the total number of returns is displayed, and the map window zooms in on the search area. Results are listed in order of acquisition date, with newer data displayed first. For results that contain Sentinel-1A data, the GRD product name will be displayed if the granule includes this processing level. A thumbnail image is also displayed if one is available. We can zoom out to get a better view of how the results cover our search area. There are a couple things to remember about how results are displayed on the map. A search will return any granules that touch the bounding box. And you can tell the orbit direction by the way a granule tile is oriented. Ascending orbits move in a lower right to upper left direction. Descending orbits from upper right to lower left. The number of granule tiles displayed on the map can be adjusted using the Show Entries drop-down menu beneath the results window. Moving the cursor over a granule in the results will highlight the granule tile on the map. Clicking on a granule in the results will open an information window or modal that displays granule metadata and a browse image if one is available. Clicking on the browse image will open a larger view which can be downloaded by right-clicking and saving the image to your computer. The information modal also shows what products are available to download. A product can be downloaded immediately by clicking the download button, or it can be added to the download queue to download later. We'll talk about the queue in the next section. Products can be added to the download queue without opening the information modal by using the queue button found with each granule in the results. Checking or unchecking a product will add or remove it from the queue. The Add to Queue by Type button at the bottom of the results window displays all the processing levels and metadata found in the results. This lets you selectively add items to the download queue by clicking on a processing level type or its metadata. As items are added or removed from the queue, the counter next to Download Queue in the top menu bar will reflect these changes. Search results can be sorted using the Find box. Enter a search term to display only those granules containing the term. Search strings can be used when enclosed with double quotes. So for example, entering 12 will display any granules containing the number 12, as well as numbers such as 124 and 312. Entering the term SLC displays the 17 granules in our results that include a single-look complex product. The filtered results are also displayed on the map. Entering the strings path 18 enclosed in quotes and frame 8 enclosed in quotes in the Find box displays the two granules in our results with these path and frame numbers. These are displayed on the map, stacked one on top of the other. I want to mention briefly that Sentinel-1 frame numbers are a bit different from those in the other data sets. Frame numbers are assigned to Sentinel-1 products at ASF during data ingestion. These are calculated based on how ESA has cut an observation swath into slices. So when searching for frames for interferometry, you may need to include a preceding or following frame to ensure sufficient coverage of an area. Another way of filtering search results is using the dataset filters. These are available after the search is complete and are located below the search parameter menus to the left of the map. A filter will be available for each of the datasets found in the results. In our example, Sentinel-1A is the only dataset we searched for. But if ALO's PALSAR had been included in the results, a separate filter for this dataset would also be included. A filter lets us apply dataset-specific parameters so that only those granules containing the parameters we've specified are displayed in the results. For example, we could select parameters and apply them to our results to identify granules that might be useful for interferometry. If we then use the Add to Queue by Type feature, we can add only the SLC products from our filtered results to the download queue. The download queue is opened by clicking the link in the top menu bar. In this example, it contains 17 SLC products from our search that were added using the Add to Queue by Type feature. The download queue lets you download both information about the products and the products themselves. You can download metadata in a KML file to view in Google Earth. The data are displayed on the map, and clicking on a tile will display information and metadata for the product. You can download metadata for the products in the queue in a CSV file. The file can be opened in a spreadsheet and sorted based on the metadata. This sorted list of granule names can then be copied and pasted into the granule list box to perform a new filtered search. For downloading the products in the queue, the most common and seamless method is to use the bulk download option. This requires using the web browser Firefox with the Download Manager Down Them All installed. Let's follow the few simple steps that are involved in this download option. Click on the bulk download button to create a MetaLink file containing the product names and locations. This file is stored in the Downloads directory on your computer. When prompted, select Down Them All to process the MetaLink file. Then set the location for the files to be saved. The last window before you start the download process displays the contents of the MetaLink file. After the download process has started, you can monitor the progress of each file. If a verification error message like this is displayed, click the Keep button and the download will resume. Vertex also has an option to download the products in the queue from the Windows or Mac command line using a custom Python script. The advantage of using this method is that bulk downloading of the queue contents can be done regardless of browser or operating system. Note that Python software already comes installed on Mac OS X computers. Windows users will need to download and install the software. Click on the Download Python Script button to populate the script with the names and locations of the products in the queue. The script automatically downloads to your local downloads directory. Windows users will be prompted to keep the file. The script is then run from the command line in the directory you want the products to download to. Detailed information and step-by-step instructions for using the two Vertex bulk download options can be found on the ASF website, as well as in the download queue itself. Well, so far we've gone through and described the features found in Vertex and used them to create a search and then filter and download the results. I think it'd be useful now to actually show you how Vertex works in a live demonstration. I'm going to create Okay, what I'm going to be doing is creating a search over an area in Central California near a town near Mendota that has had historically significant subsidence due to aquifer depletion. And what I want to do is I'm interested in looking at recent subsidence activity. And so we're going to create a geospatial search and download Sentinel data in order to achieve this result. So the first thing we need to do is get to Vertex. And I'm going to use the ASF website to navigate there. And we've got a few options available. We can use our Get Data menu and choose Find Data Vertex. Or we can use our Get SAR data card and expand the Use Vertex section and use the link that's provided there. Or we can use the Get SAR data tab to the right and use the link that's provided there. And so when Vertex first opens, you're going to be invited to use one of the interactive tours to discover the different search methods available in Vertex. I'm going to decline that invitation today. And the next thing I want to do is to get logged in. So I will use the Earthdata login link to enter in my Earthdata username and password. And what this does is it authors me through the Earthdata login system to download data from a search. So we can tell that I've successfully logged in because the greeting up here has changed to log out Bill. So the next thing to do is to get to our area of interest, and we'll use the map navigation tools to do that. Like I said, we're interested in an area in Central California, southwest of the town of Mendota. And so I'm going to be using Mendota as a reference point to locate our area of interest. And so I'm going to switch the world map to the view option that gives us place names. And so if I drag my map so that California is centered on our map, and then I can use the zoom tool to start drilling down on the map. Until the town of Mendota is displayed, and there we see the town of Mendota. So I am going to zoom in a little bit more. And here's Mendota. And this is the region of agricultural land that has experienced this historically large amount of subsidence. So I'm going to use a bounding box to describe our search area, and I'm going to anchor one corner of the bounding box on the town of Mendota by clicking once with my mouse, and then moving the mouse until it completely, the shaded area completely encloses the area, and then I will finish the bounding box by clicking one more time. If I want, then I can click inside the bounding box which it's not letting me do right now. There we go. And use these grab points to shape our bounding box to exclude the area of mountains west of our area of interest. So we've got our search area defined. Notice too that the coordinates for our bounding box are available to copy and save to use later if we wanted to replicate our search area. So the next thing we're going to do is select the data sets. And because I'm interested in recent subsidence activity, I'm going to leave the two Sentinel data sets selected because that will give us data, fairly recent data, going back to October of 2014, potentially. So we're going to leave those selected. As far as the date range goes, we're going to leave the default date range unchanged because it will encompass the total Sentinel 1A and 1B data sets in the archive. And in fact, data up to today if they are available. So we have our three required parameters set for a geospatial search. We can begin the search. Search results will be displayed to the right of the map. As you can see, we have the progress of the search displayed here, and when this progress display disappears, then our search will be complete. So our search is finished. We have found 301 granules that touch our search box or our search polygon. So if we zoom out on our display, we can see how our results are oriented relative to our search area. The number of tiles displayed on the map can be adjusted using this drop-down menu at the bottom. We can reduce the number of granules displayed on the map, or we could display them all. When we look at our results, we can see that they are displayed with newest data first. And we also notice as we move through our granule list that as the cursor is over a granule in the results, the granule location then is highlighted on the map. If we click on a granule in the results, we get an information modal that gives us a full product name. It gives us some important granule metadata. And if one is available, it will give us a browse. And if we click on the browse, we get a larger view that we can download to our computer by right-clicking and using the Save Image As to save it to our computer. Also displayed in the granule information modal here are all the products or processing levels that are available with this granule and associated metadata. So we can download a product right away, immediately, by clicking the download button next to the product description. And we can download that product to our computer. We can see that the download is in progress, and in 30 seconds will be available for us to open. We can also add the product to our download queue to download later. Perhaps we want to add other processing levels from the same granule to the queue to download, or we may want to download the same product type from different granules. But I'm not going to use that option today because I want to apply some filters to our results before I download any data. And there are a couple ways of doing that. We can use the Find button or the Find box at the top of the results. And if we enter a term such as SLC, what's displayed in our results now are 244 of the total results that contain an SLC product that would be available to download. If we enter a search string in parentheses or in quotes like path 137, what's displayed in our results now are 107 of our total results that were acquired in path 137. We can see when we look at our results that they're all from path 137. Another way of applying filters to our results is by using the dataset filters to the left of the map. These are available at the end of the search and include filters for each of the datasets that are found in our search. So since we have both Sentinel 1A and 1B products in our search results, we have filters for each. Opening a filter lets us apply parameters that we can use to filter our results. So for example, I can filter our results for interferometric wide beam mode, for VVVH polarization, for data acquired in ascending orbit mode, and apply that filter to the 1A results, and we'll open the Sentinel 1B and apply those same parameters. And we can see now that we are viewing 90 of our total results then that contain those parameters. If we zoom out on our results again, we can see that, yeah, they're all acquired in an ascending mode. And if we look at the results, we can see that they are all interferometric wide beam mode, VVVH polarization. So what I'm interested in is looking for granules that completely cover our search area, not just touch the search area, but completely include it. And so I can do that by going to our results and moving the mouse over granules until I find one that completely includes the search area. And that was quick because our second result there is what I'm interested in. So what I want to pay attention to then for that granule is the path and the frame number, because I want to apply those parameters to my filters. So if I enter path 137, frame 114 for the Sentinel-1 data in our results, and add the same parameters to our Sentinel-1B filter, 137, 114. Apply that, we can see that we have now filtered out 17 of our total results of 301 granules that contain all of those parameters. So if we can zoom out, that'll be a little clearer what we're looking for. We can see that, yes, all the granules in our results now completely include the search area. So what I can do now is I can use the Add to Queue by Type feature and add only a single processing level from our filtered results to the download queue to download. So I'm interested in the single look complex processing level. So if I click on that, I see that 14 products have been added to the download queue out of 17 filtered results. So it looks like I've probably got the data that I'm interested in. And so I will open the download queue, and we can see that, yes, the queue contents only include the SLC products. So I'm ready to download my queue contents. And since I am in Firefox, the browser Firefox, and I've already installed the download manager down them all, I can use the bulk download option to download all the data in the download queue. So I'm going to click on that button. I'm going to tell Firefox that I want down them all to deal with the metalink file that was created, which contains the information about the file name and location. We want to make sure that the download directory is set to where we want the products to end up. We have a last look at our metalink file before we start the download process. And this window then provides us the opportunity to watch the download process of each of the files in our download queue. And these SLC products are really big, and they can take a long time to download. So at this point, I'm going to wrap up my demonstration of Vertex by thanking you all for attending today. And I want to remind you that if you ever have any questions or problems concerning data or services available from ASF, please contact the ASF user support team. And thanks again to everyone. And I'm going to turn this back over to Jennifer now.
Okay, thank you, Bill. Thanks, everybody. What we'll do at this point is we will move to our final set of polling questions. And generally, I like to give these, a couple minutes or so, and from there we'll move directly to the Q&A portion of this webinar. So be sure to stay in the virtual meeting space or on the line to participate. All right, we'll give these a couple of minutes here, and then we'll move on to the Q&A portion. Okay, everybody, we're going to give the polling questions just another minute or so, and then we'll move directly to the Q&A portion of this webinar. Okay, everybody, at this point we will move to the Q&A portion of the webinar. So if you have any questions, I'd like for you to type those into the Q&A pod located on the right-hand side. And you'll note in the bottom right-hand corner of your screen that today's presentation is available for your download, both in PDF format as well as the PowerPoint file itself. And then to the left of that information, I have included the YouTube channel information. You'll be able to access this recording within a couple of days. If you're interested in downloading the files, however, after, say on Friday or so, what you'll need to do is access the recording by way of the Earthdata Adobe Connect catalog, which is accessed by way of the tinyurl.com Earthdata webinar at the bottom of the slide to your left. All right, so with that, let's see if we have any questions here. Okay. The first question is, does the bulk download work in Linux? I think so.
What?
It works in OS 10, so I think it will work. I'm not positive.
We're not positive on that.
Are you unmuted?
Can you hear me, Jennifer?
Yes, I can hear you.
Okay. We are not sure of that. We do have another couple download options to use in non-Windows and Mac environments, and those are command line options. The API, and then there's a standalone Python script that you can use to download the contents of a MetaLink file or CSV file created from the Vertex download queue.
Okay, thank you, Bill. Does this response answer your question for that participant? And if not, please feel free to email me and I will forward any additional inquiries to the User Services Office or Bill at ASF. Okay? All right, and the next question is, what is the delay of Sentinel data compared to Sentinel Hub?
I'm going to have Vicki answer that one.
Our goal is to have the delay between when it's available on the Sentinel Hub and when it's available from ASF be no more than a few hours. That can vary depending on the situation and whether there have been interruptions in service for some reason. ASF gets their data through a special NASA connection because NASA is a partner with ESA, and so therefore NASA gets the data from the ESA partner international hub and gets it to us that way. And ESA has been recently very good about putting data on the international hub the same time it puts it on the science hub, and then the NASA pull it to us and then we pull it from them right away. So it can be within a few hours of it being made available. It sometimes can be longer depending on other issues. I hope that answers the question.
Okay, thank you, Vicki. The next question is there a way to set alerts when new data matching my filter options is available to download?
No, we don't have that feature available yet, but that is something we're working towards. We'd really like to be able to provide a subscription feature to our users that could more target new data coming in, but it's not available presently. There are data feeds available, though, from our website. We've kind of designated certain super sites or recently active sites around the world that we have created data feeds for, and these can be accessed from the ASF website. And I also wanted to mention, getting back to the first question, that if you go to the ASF website and go to the Data Tools menu, there is a bulk downloads page there that will give you the different options available for you for downloading, bulk downloading from the ASF archive.
Okay, thank you, Bill. The next question is a combination question and comment. In my opinion, ASF Portal is much better for downloading Sentinel data, but the data is not complete like the ESA portal based upon my experience. Why?
Again, Vicki's going to address that question.
There's two reasons. One is there were some hiccups in the final quarter of 2016 as Sentinel-1B came online that led to some gaps in the archives that ASF received through the gateway. Those are in the process of being filled, and so hopefully any data starting in January of 2017 will be complete, and older data should be complete as well. The other possibility is that ASF only keeps the most recent version that ESA has processed. So if ESA reprocesses the data and keeps both the original version and the new version, ASF will only have the newest version. And that's a design decision that we made to make sure it was not confusing and simpler just to get the most recent version of the data.
I also want to mention, too, that prior to July 2015, ESA didn't routinely create an SLC product for all of the data it acquired. So since that time, they have been back processing their archive to produce SLC products for every granule. And so that's created a little bit of a backlog for ingestion.
Okay, thank you, Bill. The next question is, do you plan to have Sentinel-2 as well, or just radar satellite data?
No, we will only be an archive for Sentinel-1 satellites. Only radar data.
Okay, thank you, Bill. The next question is, aside from the demonstrated filter, is there a way to know if a SAR has a pair?
We're working on a baseline tool similar to what we have on URSA starting this month. So that should be delivered in a couple of months.
So that will be a tool that will help you identify in-SAR stacks.
Okay, thank you, Bill, and thank you, Jean. The next question is, any plans to implement value-added products to the image archive, for example, map-projected, radio-corrected geotiffs?
The answer is yes. There are investigations into how to generate those products for Sentinel-1 underway. The initial value-added that we're doing is the generation of the browses that are visible in Vertex. Those are not radiometrically terrain corrected, but they are geocoded and can be used for looking at data. But yes, the short answer is yes, we're looking into that. It's being explored, and hopefully within 6 months to a year, we may be able to make those available.
Okay, thank you, Vicki. This is really excellent feedback. Our next question and combined comment is, thank you very much for the presentation. It was really good. My question is, when you were going through the search results, the results were highlighted in different colors. Are these colors random or do they follow a pattern?
Those colors indicate the depth of the stack beneath it. So the hotter colors indicate a deeper stack and the cooler colors indicate a smaller stack of frames.
Okay, thank you, Jean. The next question is, what type of product should be downloaded in order to get high-resolution images?
GRDH.
You'd probably want to download the GRDH or the ground range detected high resolution product.
Okay, thank you, Bill. And the next question we have here is there free software, pardon me, for INSAR processing different to SNAP? So different than SNAP, I guess, is the...
Isn't Pulsar Pro?
Pulsar
but it's not
Pro does
free.
polarimetric.
And
I
Pulsar
thought that
Pro
was
Sentinel 1 is
tool.
integrated with Snap. We're not aware of a free software that's currently available for INSAR processing for Sentinel. That being said, I know there's an upgrade to ROIPAC called ICE that is being worked on to integrate Sentinel processing that I believe will be an open source release, but I don't know that it's available for wide distribution at this time.
Okay, thank you, Vicki. At this point, we are now into the extended 15-minute Q&A period. We do have quite a few questions, and I just want to note that if your question is not answered during the extended Q&A, not to worry, this Q&A log will be forwarded to our speakers and also our Q&A panelists, and so they will follow up with you offline with an answer, and certainly feel free also to email me, and I will get you in contact with User Services Office. The next question is, when I try to find images for an INSAR stack, I mostly find repeat pass images separated by 24 days rather than 12 days. Is this caused by missing images or Sentinel's orbit?
It's Sentinel's acquisition plan. And that may improve now that 1B is fully operational and you may start seeing more acquisitions. But there is a limited amount of acquisition time that ESA has per satellite, and 24 days was the minimal global repeat that they had put out in their original background observation plan.
Okay, thank you, Vicki. Let's see here. Okay, the next question is there a way to use a KML to select an area of interest?
No, there is no way of uploading KML or KMZ to include in a Vertex search. That's a feature that is on the list of possible additions, but currently is not available.
Okay, well, thank you for that, Bill. Our next question is, any thoughts on employing Sentinel-1 SAR data for monitoring, assessing the maintenance of large-scale infrastructures, for example, bridges, dams, in terms of space-time resolution, for instance? And if you need me to repeat any of the questions, just let me know.
That's an interesting application, and I have not heard of anyone using it for that at this point. The spatial resolution may not be fine enough, but that would be something that we'd certainly be interested in talking to whoever has asked that question in more detail about what resolution they're looking at and whether Sentinel-1. But I think that would be a longer conversation than is possible in this context.
Okay, thank you, Vicki. The next question is, how do you select global geospatial region?
we don't really have the problem with selecting global or even large regional searches is the amount of data that is found will sometimes just crash the search. And so that's one of the reasons that we have implemented the data results truncation feature, is to avoid that happening. And so we do suggest that users construct multiple searches with more reasonable search areas.
Okay, thank you, Bill. The next question is, let's see here, I need to, okay, is there a plan to include an option to store searches for users?
Yes, there is. It's not implemented yet, but it is, again, one of the things we hope to incorporate into Vertex very soon. One thing to understand is that Vertex is constantly being refined and improved on, and we do have a lot of features that users have expressed a desire for that we are working very hard to try and incorporate. And one of the reasons for the subject today for the webinar was to highlight some of the additions and improvements to Vertex that we've made since Vertex was presented several years ago. So we will probably have another demonstration of Vertex capabilities in the future.
Okay, thank you, Bill. And the next question is, the bulk download feature is really good. Is there a limit in the Firefox bulk download?
Not that we're aware of. We've used it for downloading hundreds of files simultaneously.
Okay, thank you, Bill. The next question is, this might be a little out of scope, but what is the difference between frame, path, and absolute orbit?
Frame, path, and path are ways of designating a specific spot on the Earth that a repeat orbit goes over. So the path of the satellite every cycle repeats over that particular patch of dirt. The absolute orbit is the number of orbits that the total that the satellite has made.
So the path is equivalent to the relative orbit, which is how ESA would describe it. And the frame number, again, is something that has been added to a granule as the products are ingested at ASF. ESA does not assign frame numbers to their data products.
Okay, thank you, Bill. And then the next question here, can path, frames, tile footprints be seen somewhere?
All the results are displayed on the map. What we have added is some transparency to that tile map, because what we found in the past was that if you had a lot of results, it would tend to obscure the map underneath it, and people really wanted to see where on the map granules were located. But we do not have a map of paths available. So I guess I guess I don't understand the question completely, but there really is no way yet of visualizing a stack, in-SAR stack, other than, like Gene said, to note the color of the tile, and the color will indicate the number of granules that make up that stack. So the hotter colors, towards red, are more granules, and the cooler colors are fewer granules. But with the delivery of the baseline tool to Vertex in the next couple of months, we should be able then to provide a way of visualizing a stack.
Okay, thank you, Bill. And there was actually an addition. This particular participant said, sorry, I meant like a filtering option equivalent to path rows, but I think you just explained why ESA does not assign frame numbers. Like
Right.
here for the Landsat series to search by path rows to find temporal series for the same area.
Right.
Okay, and now getting back to, there was a comment earlier, which I believe everyone can see now. ICSC currently supports S1 processing download via WinSAR, and this gets to an earlier question. And then moving on to our next question, is there any way we can get the answers to the questions asked? I need to go to a meeting. Okay. Yes, Young, the recording will capture this information. And certainly if you have additional questions, feel free to email me and we can put, get the question out to the ASF user support office. Okay, so the next question we've got here, in searching for images for an INSAR stack, you mentioned that we should use frame number plus or minus 1. Can we enter a range of frame numbers?
No, I think what you would need to do would be to enter the frame numbers as separate strings enclosed in quotes in the find box. So you should be able to enter multiple frame numbers enclosed in quotes in your find box, and it will select for those.
Okay, thank you, Bill. Let's see here. Just sorting through, bear with me just for a moment here. There's some comments as well in response to previous questions. Okay. The next question is, what is the critical baseline for S1AB doing INSAR?
We don't know that yet. That's what we are working on right now in developing the baseline tool. We need to establish what the baseline is for Sentinel-1.
We're working with members of the INSAR community to try and establish that.
Okay, thank you, Vicki. Right, are there any further questions? We've got about 5 minutes left to the extended Q&A period. And just a couple of notes. What we'll do after the Q&A is complete at 4:15, I will leave the virtual meeting space open an additional 10 minutes or so to 4:25. So if you think of a question, feel free to enter that into the Q&A pod, but we will log off from the telecon or audio component of the webinar. Any further questions?
I have a comment to make, Jennifer.
Sure.
Just to let our users know that they should kind of experiment with both the find box and the data set filters. Use those, and also the add to queue by type feature, and find the right combination for coming up with the sorting mechanism that serves them best. There are different ways that you can use them in combination, which will kind of really fine-tune a sort and what ends up in your download queue. And then you can always use the download to CSV file and open up the metadata for the contents of the download queue and do a lot of sorting and filtering in a spreadsheet environment, and then use those results to paste granule names into the Granule Search function.
Okay, thank you, Bill. And I just wanted to confirm something. Your user support email address is asf@asf.alaska.edu. Do I have that correct? Because I will type that into the Q&A pod.
The user support email address is uso@asf.alaska.edu.
Okay, Bill, thank you. And just to repeat that, it is uso@asf.alaska.edu.
Correct.
Okay, I'm going to send this out to everybody. All right. Are there any further questions? If there are no further questions, I'd like to thank all of you for joining us this afternoon. We had some excellent questions today. Our next webinar will actually be held on March 22nd and may not be, I don't know how many of you might be interested, but we'll be featuring ocean biology data, services, and tools at the NASA Ocean Biology DAAC, which is here at Goddard Space Flight Center. All right. All right, well, thanks everybody. At this particular point in time, we will log off from the audio component of the webinar. I will leave the virtual meeting space opened. And if you think of anything, go ahead and type that into the Q&A pod. And again, within a couple of days of completion, I will send a thank you out with a link to the YouTube URL, as well as the direct link to this recording, where you'll be able to download the presentation files should you be interested. And thank you so much. All right, well, thanks, everybody. Thank you, Bill, Vicki, and Jean for joining us. That was fantastic.
Thanks, Jennifer.
You're quite welcome. Bye-bye now.